I'm Dominik. I'm with Polygon Meiden, and with Polygon Meiden we try something new. And our thesis is that privacy scales better. So normally when we look back, when we try to add privacy to a blockchain, normally it was more expensive and slower because we encrypted stuff or because we tried to hide it in another way. But my thesis is that zero-knowledge proofs take in not only the succinct property of zero-knowledge proofs, but the zero-knowledge property actually leads to blockchains with thousands of TPS for the simple reason that state and execution can be locally at the user's computer, and the blockchain is super slim and can only verify. And using this concept, we can build new things. So this is what I want to talk about today. Like this, yeah. So, and with our new blockchain architecture, you can build new things, and also Alexander will join the stage and explain what he's building. But basically, just a very quick rundown. We architectured our blockchain in a way such that users prove their own state transitions with zero-knowledge proofs. Like in super simple terms, it looks like this. Here's some user, he says, I did something, you don't know because it's zero-knowledge, but here's the proof what I did. And everyone says, okay, yeah, that's correct. So you applied to our rules. And this is how you can construct a blockchain. So the core principle is that users generate their own zero-knowledge proofs. Obviously, that leads to privacy, because the network has zero knowledge about your statement, about your state transition, if you want to. But it also leads to way better scalability, because the blockchain doesn't need to, and it cannot even, recompute the whole state. It just has a commitment to your state, and you can change this commitment using a zero-knowledge proof. And even more, like Meiden, you can use it privately, as I explained, but we can also use it, like there's also public shared state on Meiden, and then it works like just a normal blockchain. So there is public state stored in the nodes that produce blocks. And this is for smart contracts. I will explain in a bit. But the user can choose to stay private and to have it way cheaper. And the more users choose to stay private, the better the network scales. So quite quick rundown on the Meiden architecture. So in Meiden there are accounts and nodes. So we mix together the Ethereum account model and Bitcoin's UTXO model just because we need accounts for smart contracts. There is currently no better way. And we use nodes for parallel transaction execution and privacy. When you understand how a transaction works in Meiden, then I always say you understand the whole thing. So give me 1 minute. A transaction is defined as the state transition of a single account. Right? So remember, a transaction in Ethereum means Alice sends something to Bob, or we can involve many more accounts into this one transaction. But in Meiden, a transaction means account A changed its state from S to S prime. And in doing so, like here in this case Alice, she can consume some nodes and produce some nodes in her transaction, and these nodes can carry assets. So she can get assets by consuming nodes or send assets out by creating nodes. And because for every transaction there's always a zero-knowledge proof, and because every transaction always involves only one single account, the user has all the information to create the CK proof about its own state transition. That's the whole concept behind it. And that leads to parallel transaction execution because they can, like, it's asynchronous. It's a bit like in the actor model of databases. So accounts are our actors, and they get state changes get triggered when they get when they receive new nodes, and then they can trigger state changes in other accounts by pushing nodes to them. And then, as I said, like in Maiden, you have this private and public, and the possibility to store your whole state locally, and then the network only knows a commitment of your state, or you can store the whole state publicly, and then it is like on Ethereum, right, or in any other smart contract blockchain where you have public shared state, and users can interact with it, can manipulate the state, everyone can read it, and you can interact with it and create and consume nodes against these accounts. And this hybrid basically allows us to build novel applications. So for example, in Maiden, it is possible to create private central limit order books, which is a nice application because it could be fully non-custodial. The user owns all its assets, and you could have the same UX as you would have on Binance. In Maiden, you can build perp markets in a special way because in one transaction you can consume in theory thousands of nodes and create thousands of nodes. So in one single transaction you could serve thousands of users. And a very nice use case for Maiden, in my mind, is provable compliance. And provable compliance means that, in theory, I can locally prove that I complied to certain rules. For example, I did not interact with a list of OFAC addresses. And then I create this transaction locally, and I send the proof to the network, and the network and no external observer will ever know to whom I transacted with, but everyone knows that I complied with a certain set of rules, as long as I can encode these rules in a smart contract. And this is actually super cool because this is not possible in blockchains where you don't have client-side proving. So you can stay private and prove the compliance with certain rules at the same time. But enough for me. I want to ask Alex on stage. He's building something cool, something new in Maiden, and it's better to hear from him.
Hey everyone, my name is Alexander Lee, and thank you, Dominik, for letting me speak today. I'm going to be talking about how we are building a privacy-preserving, state-minimized central limit order book on Polygon Maiden. How do I go forward on this thing? The green. Perfect. Okay. All right. But before I begin, why are we building a privacy-preserving central limit order book to begin with? I think many of us in the Web3 space can agree that financial sovereignty and privacy are extremely important. But right now in the blockchain space, there really aren't that many privacy-preserving protocols. Yeah, we have Monero, we have Zcash, we have Tornado Cash, but it's kind of sketchy to use Tornado Cash now that OFAC sanctioned it. So by building on Polygon Maiden, we are supporting essentially a privacy-preserving protocol. But it's also important to state that a privacy-preserving central limit order book isn't essentially the main goal. It's just like this really cool added bonus of building on Polygon Maiden. I just think it's so cool that you can create like an order book where people can be exchanging assets. You have no idea who is exchanging these assets, the amounts they're exchanging. So I think it's just super cool that we can build this on Maiden. Another reason why we are building a central limit order book as opposed to, for example, an AMM is that central limit order books, they are much more capital efficient than AMMs. For example, and capital efficiency was sort of improved on Uniswap v3 with the concept of concentrated liquidity. However, most of the liquidity on the AMMs, it's just sitting there idly. It's sitting in the smart contract and it's not really being used. But you don't have that problem on a central limit order book. Another problem when you are supplying liquidity to an AMM is that two things essentially. You are receiving like this derivative. So like you deposit liquidity into Uniswap and you receive this LP position, and as the price fluctuates of the volatile asset, you have this new risk. And this new risk profile of this position, this LP position, is very similar to a covered call option. And this creates a bunch of new problems, because now you have to hedge the risk of this covered call option, or sort of like the LP position. And it creates this whole category of, or subcategory of DeFi protocols that honestly I don't know are necessary. I'm not hating on anyone, I'm just saying this is added complexity that you can just cut out with a central limit order book. Another thing is essentially when you are supplying liquidity to an AMM, you are short volatility. So if you supply liquidity to Uniswap v3, you are essentially making the bet that you want there to be no volatility. And you don't have that problem on a central limit order book. All right, so how does Miden differ from EVM? So I'm a Solidity, or before I was working with Composability Labs building a central limit order book, I was working a lot with Solidity. So how does it differ, if anyone here is like experienced with Solidity, how does it differ building on Miden as opposed to building stuff with EVM? So accounts, by default, all accounts, it's like native account abstraction on Miden, so all accounts are smart contracts. But the main difference is notes. Notes, like Dominik said, are essentially UTXOs. And inside the UTXO, you can have a script that defines how that script or the note, the UTXO, can be consumed. So UTXOs, notes, they can have data inside of them, and they can also contain an asset. And what I really like about notes, I like thinking of them as like these cryptographic cashier's checks. In the US, cashier's checks are super popular because like someone can write a check and they don't actually have the money in their bank account for that money to clear. So if you like receive a check, the person might not actually have the liquidity in their bank account. But with a cashier's check, you are certain that that person, when they give you the cashier's check, 100% they have that money in their bank account. So notes are sort of like the cryptographic version of cashier's checks. And the really cool, what I think is super cool about Miden notes is that they sort of enable verifiable computation. So you can essentially prove that some smart contract X did some computation Y with some input Z. So let me give you a concrete example. So if you were building some sort of, I don't know, like lending protocol on Aave, the lending protocol could have like snapshots at different discrete time points, like saying I have some amount of liquidity at this discrete time point, and some other smart contract in the future could consume those snapshots of that lending protocol. And that smart contract consuming the UTXO, that note, would be 100% certain that the liquidity actually existed. So I think this is so cool. It's like this verifiable computation at the blockchain level. So any central limit order book that's being built on Polygon Miden is using notes as like the core of the exchange. All right, so now let's talk about the actual core of what we are building. It's this thing called the partially fillable swap note. So right now on Miden base, there are 3 default notes. There's the P2ID note, which is pay to ID note, which is just a simple liquidity transfer. Then there's the P2IDR note, which is a simple liquidity transfer, but then the person who created the note can also reclaim the note. And then there's the third type of default note, which is called the swap note. And the problem with the swap note is that it is not partially fillable, meaning let's say you have Alice and she is selling 10 tokens A for 10 tokens B, and then you have Bob comes along and he likes the price of the tokens that Alice is selling, but he only has 5 tokens B. He cannot fill that order with the default swap note. So that's what we're building. We're building this partially fillable swap note. So what happens? So with a partially fillable swap note, you have trader 1, Alice, has 10 tokens A, and she wants to sell these 10 tokens A for 10 tokens B. Then you have trader 2, who is Bob, who only has 5 tokens B. So inside of this partially fillable swap note is the logic that would output a P2ID note, which is the 5 tokens B, and would also output another partially fillable swap note with the remaining liquidity of Alice that wasn't filled by Bob, essentially. And this process of like partially filling notes can continue n number of times until the note is completely filled. So this is how the partially fillable swap note works. And what's cool about these partially fillable swap notes is by default, they act as buy-sell limit orders without having to change the logic to the partially fillable swap note at all. All you have to do is essentially just state that you want to buy an asset. Like, let's say you want to buy, create a buy limit order. So you think that the price of the asset, the volatile asset, is going to decline on the market. All you have to do is essentially set the price that you're wanting to buy an asset in the swap note at lower than the market price. And the buy limit order wouldn't get filled because any rational market participant isn't going to consume your buy limit order before some other notes that exist in the market, other buy-sell limit orders in the market. And what's cool is once you start aggregating these partially fillable swap notes by price and by amount, you can start seeing this order book depth chart. So yeah. All right, so what are we working on next? Right now we have partially fillable swap note. It's all open source, so if you guys are interested in learning on how to write smart contracts and notes on Polygon Maiden, I have a QR code at the end that you guys can check out. I was talking to some Wintermute guys the other day, and I got some feedback from them. So it's super important for market makers to be able to batch cancel buy-sell limit orders without submitting a transaction. So that's something I'm going to have to work on in the partially fillable swap note. That's probably going to take like a week or so. But then the next couple of weeks, we're going to be working on matching these buy-sell limit orders, or just buy-sell orders on testnet. Then there's this really cool thing that was recently pushed to Maiden called delegated note inclusion, which essentially you can have that chain of transactions of like matching buy-sell limit orders off-chain and then settle it completely on-chain. So that's we're going to be working on that as well. And we're also working on a perpetual futures exchange. But the problem with perpetual futures exchange right now is sort of like we're researching how it can be state minimized, because right now with buy-sell limit orders, it's, everything's matched. So yeah, and we're targeting mainnet launch Q1, Q2, 2025. So thank you so much. If you have any questions, if you want to learn how to write smart contracts and notes on Maiden, check out our repository. So thank you so much. If you have questions for Dominik or me, feel free to ask. Buy-sell limit orders, everything's matched. So yeah, and we're targeting mainnet launch Q1, Q2, 2025. So thank you so much. If you have any questions, if you want to learn how to write smart contracts and notes on Maiden, check out our repository. So thank you so much. If you have questions for Dominik or me, feel free to ask.